Welcome to this GHS tutorial on structural analysis. Tutorial number 730 focuses on using waves. So today we are specifically going to cover just how to apply waves. That's all there is to this. This is something typically done for longitudinal strength analysis. It's a quasi-static analysis, and we're going to show how to do it. But first, a disclaimer. This presentation is for instruction only. It is not to be used in engineering for construction, and I am not a representative of Creative Systems. This is unofficial training only, based purely on my own personal knowledge and experiences. For the official training, you can contact Creative Systems at the information listed at the bottom of your screen. I highly recommend the training. It's quite informative. So, what are we talking about today by adding waves? This is used in quasi-static analysis, situations where you're really looking at a dynamic sea-keeping analysis, something that might go beyond GHS's capabilities, but you can still do quasi-static analysis as a first pass. Again, it's a preliminary investigation. And the way it works is that GHS changes the shape of the water plane. Up until this point, the water plane has always just been a flat plane. But now we're going to actually change that shape with waves on top of it. And that's going to change the buoyancy distribution of the hull. And so you're going to have to resolve for equilibrium. And when you couple that with a longitudinal strength analysis, you can see how that's going to bend your hull, what sort of deflections it'll create, what sort of bending stresses. So that's how that works. Now, I should also mention that when we talk about adding waves here, we're not talking about a full wave spectrum. What we're talking about instead is specifically just, what's the word for it? What we're talking about is specifically just a single wave profile. That's what I wanted to say. So, not a C spectrum, just a one wave. And it's up to you to figure out what that wave is supposed to represent. Okay, so the GHS command for this is wave, and there are several different parts to it. You have the wave command, then you specify the specific type of math used for that wave to describe its shape. Then you have a phase, a length, and an amplitude. Now, what are all of these? First off, the form, that's the wave equation used. So these are the shapes of waves. Now you can have a trichoid wave, a sinusoidal wave, or a Stokes wave. Trichoid waves are probably the closest to what waves are supposed to look like in reality. But you also have sinusoidal and Stokes waves, both of which have uses in other forms as well. So all three of these get used depending on which regulations you're looking at. Now the phase, that's going to be the phase angle of the wave. This is a number that's between 0 and 360 degrees. So it is measured in degrees. And if you have a phase of 0, then the crest of your wave is going to be wherever your origin is on your model. If you have a phase angle of 180, the crest of the wave will be at the middle of your wavelength. And speaking of wavelength, that is now the next parameter that you put in, and that's whatever the current length units are in. And then finally, you have the wave amplitude. Now, this is actually the crest to trough height. So some of the more specific people would actually say this is the wave height, not actually amplitude. And again, that height is specified in whatever your current length units are. So here are a few examples. We've got wave TRO at 0, 350, and 3. So the TRO tells us it's a trichoid wave. The 0 is the phase angle. So this is 0 degree phase, meaning the crest is right at your origin. 350 is our wavelength. So that's a 350 meter long wave. Usually your wavelength is going to be set to match whatever your ship length is. That usually creates the worst condition. And then 3 stands for a 3 meter wave amplitude, which is actually the crest to trough height. Another example, you can type wave sine, S-I-N, at 180, 106. That's a sinusoidal wave at a phase of 180 degrees. So that's putting the crest right in the middle. Since it's a 100-meter long wave, that means our crest is at 50 meters, and it's a 6-meter amplitude, 6 meters from crest to trough. So those of you technically minded will actually say that's a 6-meter wave height. Okay, now you can turn the waves on. You also need to be able to turn them off. The way you do that is wave off. That's the GHS command to turn off waves. Right, best way to learn this is to practice it. So homework number 731, I'd like you to start with the information that we have in homework 711, and that's a longitudinal strength analysis. And you're going to add the following wave definition. A sinusoidal wave with an amplitude of 3 meters, a phase of 180 degrees, and a length of 100 meters. Once you've put that wave definition in there, run longitudinal strength. And then I want you to repeat this, turn off the current wave, add a new wave back in with a Stokes wave, amplitude of 5 meters, a phase of 0 degrees, and a length of 30 meters. So the right here with the phase of 180 degrees and 100 meters, you should see the crest of your wave right at midships on the barge. And for this other one with the phase at 0 degrees, length of 30 meters, you should actually see the Stokes wave repeat a few times along the length of the barge. And in all cases run longitudinal strength. You'll notice you get a higher bending moment. Also, don't forget, you've added in a wave, you've changed your buoyancy distribution, which means you need to resolve. You need to re-equalize your vessel. Okay, well, thank you very much for watching. I hope you found this informative. You can find the homework files along with the solutions and other tutorials online at dmsonline.us. Thanks very much.
Thanks for watching. I hope you liked it. Hey, did you know that there is a magic button down below? Click the like button or even the subscribe button and I will make more videos for you.